So whenever two wires which are carrying the current, they produce a magnetic field. So example, now we are finding the force on A on to due to B. So this is wire A, cross means it is carrying current into. Then there will be wire B. The wire B also cross means it is carrying the current into. So both wires are carrying the current into. Now, if I want to find the direction of a magnetic field of B, so how I will find the direction of a magnetic field? To find the direction of a magnetic field, we'll always use a right-hand grip rule. Cross means my thumb should point in and dot means my thumb should point out. Because it is a cross, so my thumb is pointing in and my fingers will turn around it. So as a result, the direction of a magnetic field of B is also clockwise because the current is in the same direction. So the first two field lines should be closer, shows a stronger magnetic field. Then the third and fourth should have a greater distance between them, which shows that the strength of a magnetic field is decreasing. So when we represent by the arrow, so again, it will be a clockwise. So this is the direction of a magnetic field. Now, if the question is, what is the direction of the force? Force on A. Now, how to find the force? Because A, the wire A is in a magnetic field of B and B is in a magnetic field of A. So if you want to find the direction of the force, we have to use a second rule that is known as the Fleming's left-hand rule. So my index finger point in the direction of a magnetic field. So for A, the index finger should point upward because the direction of a magnetic field is up. My second finger represents the direction of the current because the current is into. So my second finger should point into. Where my thumb is pointing on the right hand side. So what will happen? What will be the direction of the force? So the direction of the force for A, it is on the right hand side. So this is the direction of the force on A. And when we work out the direction of force on B, it will be opposite. We work out like we'll have A and we will have B. A produces a magnetic field and these magnetic field lines will pass through B. So first we use two rules. Number one, the first rule is the right hand grip rule. The right hand grip rule is used to find the direction of a magnetic field. We'll use a right hand. But to find the direction of the force, I will use Fleming's left hand. So my index finger point, the thumb point in the direction of a current, which is into, and the fingers will turn around. So the direction of a magnetic field is around. So this is how the magnetic field lines will point. Now to find the direction of the force on B due to A, for that we will use, if we want to calculate the force on B, we will use left hand. And the first thing to draw the magnetic field, we'll use the right hand grip rule. So first we use the right hand grip rule to get the magnetic field. And after knowing the magnetic field, we'll find the force on B due to A. So my index finger should point in, I will use the left hand, my index finger should point in the direction of a magnetic field, which is into, which is downward. Cross means the current is into, my second finger point into, and my thumb is pointing in the direction of the force. So it means the direction of the force is towards the left hand side. So when two wires are carrying the current in the same direction, what will be the direction of the force when we work out? So when we work out the direction of the force, we'll always find when two wires are carrying the current in the same direction, they will exert force on each other, and the direction of the force on each other, that is towards each other. And same way, if we have two wires, like example, they're carrying the current out. Dot means, cross means the current is going in, and dot means the current is going out. So example, this is wire A, which is carrying the current out, and there's also wire B that is also carrying the current out. And I want to find the direction. First, I want to find the magnetic field of A. So how to work out the magnetic field of A? So if I want to find the magnetic field of A, the rule which we will use right hand grip rule. The right hand grip rule is used to find the direction of a magnetic field. So I should use right hand. My thumb should point in the direction of the current. Dot means out. So my thumb should point out, like out of the screen. And my fingers will turn around it. So which direction my fingers rotate or turn, that is the direction of magnetic field. So direction of the magnetic field is in opposite direction, or we can say the previous, it was clockwise, but now it will be anti-clockwise. And these field lines will pass through B as well. So that is first part. We work out the direction of a magnetic field. The second part, how to get the force on B. So to get the force on B, I have to use Fleming's left hand rule. So to find the force on B, I have to use my left hand, my index finger. My index finger should point in the direction of a magnetic field. So magnetic field is pointing according to B. Like for B, the magnetic field of A is pointing up, so that magnetic field is up. My second finger represents the direction of the current, because for B, the current dot means out. So my second finger should point out. So my index finger is pointing up, my second finger is pointing out. Where my thumb is pointing, that is on my left hand, towards my left hand side. So the direction of the force on B due to the magnetic field of A is towards the left hand side. So this will be the direction of the force. Same way, I can find the direction of the force on A due to the magnetic field of B. So example, this is wire A, this one is, and both are dot, means the current is out of the plane. So this one is A, the other one is B. When we draw the magnetic field lines for B, I will use the magnetic field of a B. So to get the magnetic field of B, again, I will use my right hand grip rule. My thumb should point in the direction of the current and my fingers will turn around it. So dot means the current is out. So my thumb should point outward and fingers will turn around. So the direction of a magnetic field of B, which is passing through A, that is also anti-clockwise. So to get the direction of a magnetic field, we will always use right hand grip rule. The second part is, so to get the magnetic field of B, we will use a right hand grip rule. Now to find the direction of the force, so to get the direction of the force, how we can work out the direction of the force? The simple way to get the direction of the force is Fleming's left hand rule we can use. So my index finger should point, I will use a left hand, my index finger point in the direction the index finger is pointing in the direction of a magnetic field, which is down. My second finger is pointing in the direction of the current, because the second finger, it should point outward. Where my thumb is pointing in the direction of the force. So this wire will experience a force that is towards the center as well. So simple idea is that whenever two wires are carrying it, even without using the rules, I just use the method, the technique, generalize the result. So what I can say, whenever two wires are carrying the current in the same direction, like if wire A and wire B, they are carrying the current. So if two wires are carrying the current in the same direction, what will be the direction of the force? Even without applying a rule, I can generalize this, that the force is always towards the center. Like they will try to move towards each other. And same way, if the direction of the current for both wires, it is same but downward as well. But it is same direction. So what will the direction of the force? Again, the direction of the force is towards center as well. So they will try or move towards each other. And if two wires are carrying the current into, cross means into, so what will be the direction of the force? The direction of the force is also towards each other. And if two wires are carrying current in opposite direction, in dot means out of the plane, but they are carrying the current in the same direction. So what will the direction of the force between them? So the direction of the force is also towards the center. So direction of the force when the wires carrying the current in the same direction is always towards the center. And it will be opposite if we change the direction of a current. Like example, if one wire is carrying the current up, the other is down. Or one is down, another one is up, one is cross, another one is dot, or one is dot, other one is cross. So these are the four cases, four scenarios. So if two wires are, maybe two wires, one is carrying up, other down, one is down, the other one is up, and one is cross, like one is in, carrying a current in, another one is out, and one is out, the other one is in. So you can see the direction of the current is opposite. So whenever direction of the current is opposite, what will the direction of the force for all of them? Because the direction of the current is opposite, so they will tend to, the two wires will try to repel each other, or they will move away from each other due to the interaction of their magnetic field. So simple rule is there. Whenever two wires, current carrying conductor, carry the current in same direction, they tend to move towards each other. And when they carry the current in opposite direction, they tend to move away from each other. So this is a simple rule. You can just remember, if wires carrying current in same direction, they tend to exert force on each other and tend to move towards each other. Carrying current in opposite direction, then they tend to move away from each other. So as you can see in this image, when two parallel wires which are carrying the current in the same direction, so they both move towards each other, or direction of the forces towards each other. But if they carry the current in opposite direction, as you can see, one is carrying the current up, another one is down. So what is the direction of the force? The direction of force will be opposite. So this is the exam style question. Figure 9.1 shows an apparatus which is used to investigate the electromagnetic effect around a straight wire. So there's a straight wire. T1, T2 is a rigid wire, and T3 and T4, that is a flexible, thin flexible wire. Figure 9.2 shows, figure 9.2 is a view looking down on the apparatus as shown in figure 9.1. So we're looking from the top. That is how it looks like on this. A battery is connected to T1 and T2. So there's a battery connected T1 and T2, and there's a current vertically downward. So if the current is vertically downward, so what it appear, as you can, so if the current is vertically downward, so current is from T1 to T2. So means the current is into. So if we know that current is into, how to draw the direction of magnetic field for figure 9.2. So my thumb should point in the direction of a magnetic field, direction of the current, sorry, and my fingers will turn around it. So thumb is pointing because the current is, according to the first figure, it is downward. But when I look from the top, it is into. So my thumb should point in the direction of a current which is going into the paper, and fingers will turn around. So the direction of a magnetic field, we have to draw 3 magnetic field lines. So first 2 field lines should be closer, which shows stronger magnetic field, and the third one should have a greater spacing. And the direction, it will be clockwise. So these are the 3 field lines which we draw with an arrow. Then using a variable resistor, the potential between T1 and T2 is gradually reduced. Like first maybe 5 volts is there, but now we reduce this 5 volts to 2 volts. So what will happen to the strength of a magnetic field? So if voltage we reduce, the current will also change. As a result, when there's a change in current, so the strength of a magnetic field will decrease. You can write reduce, or you can write decrease, or you can write and the direction of a magnetic field, because we are not changing the direction of a current, so direction of a magnetic field will remain same. In this question, there is a small confusion here. Like normally, as I mentioned, when it is cross, it means the current is into. When it is dot, it means current is out. But when you see this, it appeared to be a dot, so the current should be out. That is the confusion. But as you read the question, actually this dot is not for representing the direction of a current. This dot is only representing a place where the wire is passing. So this dot, they don't mean to show the direction of a current. This dot, they mean to represent that this is a place where the wire is passing through. So maybe when you look at this dot, it looks like according to this dot, there should be a current outward, and I should use a right hand grip rule. So direction of a magnetic field will be in opposite. But it's not the way, because in this question, this dot here, they just refer that this is a space where the wire is, maybe they can use a complete dark part so that it will be easy to identify. So they're just representing a direction. They're not representing a direction of a current. They're just locating a place where the wire is passing through a cardboard. That's why they use this symbol appear as a dot. But it does not mean the direction of a current. Direction of the current, they already specify here that the current is vertically downward. So if a current is vertically downward, so what will the direction of a magnetic field? If I apply my right hand grip rule, so you can clearly see that the direction of a magnetic field will be, my thumb point in the direction of a current and my fingers will turn around it. So this is how the magnetic field will look like. And when you look from the top, the pattern will be similar to this. But we don't have to draw on figure 9.1. We have to draw on figure 9.2. Then the second part, the battery is now connected to a terminal T3 and T4. So the T3 and T4 are also connected now. And there is also a current downward. This causes a flexible wire to move. Explain why the flexible wire moved. That's a question they ask. Like there was already a current which is passing through T1 to T2. Now there is another current which is passing from T3 to T4. The question is why the flexible wire move. Rigid wire, both should move, but because rigid wire means it does not move easily. So what is the reason for that? The reason is the two wires which are carrying the current produces the magnetic field. So your answer will be wires, two wires carrying the current produce magnetic field which the two wires, both of the wires are producing a magnetic field which cuts or interact with each other. The two magnetic field interact with each other and exert force. So the answer for the part C, that why the wire, flexible wire move. So the answer is two wires which are carrying the current, they produces a magnetic field, and these magnetic fields are actually interacting with each other. As a result, when these magnetic fields are interacting, they exert force on each other. Then state the direction of the movement of the flexible wire. So as I mentioned, whenever two wires are carrying the current in the same direction, so what will be the direction of the force between them? So the two wires, when they carry the current in the same direction, so the direction of the force is towards each other. So which direction the flexible wire will move? Because if the direction of the force is towards the center, so I can say it will move towards this is a flexible wire. So which direction it will move? It will move towards the right hand side, or we can say towards the rigid wire. So answer for this part, direction of the movement, and that is towards right hand side or towards the rigid wire. A battery is replaced by one that deliver a small current. State the effect that this will have on the force acting on the flexible wire. If the current reduces, the strength of a magnetic field will also decrease. As a result, what will happen? The force will decrease as well, or it will reduce the force experienced by the flexible wire. In this question, two straight vertical wire X and Y passing through hole in the card. The figure shows a view from the top, from above or top. There is a current in each wire in downward direction or into the page. So they mention here the current is into. They mention the magnetic field at Y. The magnetic field at Y is due to X that produces a force on Y. Place a tick in each blank column of the table to indicate the direction of a magnetic field and the direction of force. So my direction of a magnetic field, they already mentioned that this Y is in a magnetic field of X. So how I can work out the direction of a magnetic field? So I have to use right hand grip rule. So my thumb for X, my thumb is pointing into and fingers will turn around it. So what will be the direction of a magnetic field of X? That will be clockwise, and these magnetic field lines will pass through Y as well. As they already mentioned, the magnetic field at Y is due to current in X. So there is a current in X that produces a magnetic field, and this magnetic field lines are passing through Y. So what is the direction of a magnetic field for this wire Y? So it is bottom of the page. You can see it is downward or bottom of the page. So towards the top of the page, towards the bottom of the page. So I should take towards the bottom of the page. And without applying a rule, I can also work out, because if two wires are carrying the current in same direction, so what will be the direction of the force? Without applying a rule, I can say they will move towards each other. So what is the direction of force on Y? So the direction of the force on Y is towards left hand side. But I can also use the Fleming's left hand rule to work out this. So according to Fleming's left hand rule, my index finger point in the direction of magnetic field, which is down. So index finger is pointing down. My second finger represents the direction of the current, because across means the current is into. So index finger is pointing downward. My second finger represents the direction of the current, which is into. And my thumb is pointing on the left hand side or towards the left hand side. So the direction of the force. So the direction of the force on Y due to X is towards the left hand side.